Welcome to Ridgy. Now we are continuing the session of system of circles here. In that, the topic name is radical axis. Radical axis. Let us see about the radical axis here. First of all, let S is equal 0, that is nothing but S is equal ax square plus y square plus 2gx plus 2fy plus c is equal 0 and s dash is equal 0. S dash is equal, here I am taking s dash is equal x square plus y square plus 2g1x plus 2f y1y plus c1 is equal 0. S dash is equal to, otherwise you can take g dash, f dash, c dash here is equal 0. And these two circles I am drawing here. I am taking two circles here. I am two circles having of center C1 and having of center C2 here. So this is S is equal 0. This is S dash is equal 0 here. These are the two circles here. Radical axis is nothing but I am taking a point P. I am taking a point P, that is P of x comma y. P of x comma y here. So the power of this point, the power of S is equal 0. Power of S is equal 0 at P of x comma y is nothing but S11. S11 is a value here. S11 is a value, this is a value. If you substitute point x comma y value in the equation of circle, will get some value, that is nothing but S11. And in that way, similarly, if you substitute a point P of x comma y in the circle equation S dash is equal 0, that is nothing but power of S dash is equal 0 at P of x comma y, that is nothing but S1 S dash 11. This is also value. If S minus S is equal to H11 is equal to S dash 11, in that way similarly at point P of x comma y, at point P x comma y, and if you take one more point, that is, if you take one more point, I am joining here. So this is one point, and I am taking one more point at point Q. I am assuming this is a point Q of x1 comma y1, and at this point also the power of S is equal to S11, and at point Q the power of S dash is equal to S dash 11. Here we are getting, and so I am joining these 2 points. These 2 points here. Similarly, I am taking one more point at downside. So this is PQ, or I am considering. So at this point also the S dash of H11, the power of point H11 is equal to, is a value, S is equal to 0 is a value, and S dash 11 is also value here. So the collection of all these points, the joining of all these points all these points is called radical axis. This is nothing but radical axis. Radical axis. So similarly I am taking here, observe clearly. So H11 is equal to always H11 is equal H dash 11 x square, H1 is equal to H1 is equal to H dash 11 and x square plus y square plus 2gx plus 2fy plus c is equal to and x square plus y square plus 2 dash x 2g dash x and 2f dash y plus c dash, and here x square get cancelled, y square and y square get cancelled. So the remaining terms are 2gx plus 2fy plus c is equal to 2g dash x plus 2f dash y plus c dash. Let's bring all the terms to left hand side, then it will become 2 of g minus g dash into x plus 2 of f minus f dash, directly I am writing f dash into y plus c minus c dash is equal 0. This is a straight line equation, that is nothing but in the form of ax plus by plus c, ax plus by plus c. Here this is a straight line equation here, and from this straight line here 2gx plus 2fy is from this straight line. The slope that is equal to m1, that is equal to slope of this one is equal minus a by b. So minus a by b is nothing but g minus g dash by f minus f dash. This is the slope of this straight line here. This is the condition, and if you draw the joining of C1 and C2 here, slope of M2 is nothing but C1. This is a point of, I am considering minus g comma minus f and minus g dash comma minus f dash. So these are the centers. The distance is called square of that value is nothing but the ratio of that one is f minus f dash by g minus g dash. So yeah, if you multiply m1 into m1 into y2 minus y1 by x2 minus x1, if you substitute like this, we will get the slope. This first slope of these two lines, this line is, so m1 into m2, that will become g minus of g minus g dash and f minus f dash into f minus f dash by g minus g dash. So g minus g dash and f minus g minus g dash, f minus f dash, both are cancelled. So final one is equal to minus 1. If the product of two lines, the slopes of product of two lines is equal to m1 into m2 is equal to minus 1, then the lines are perpendicular each other. Here the radical axis and the center of a line, this is called center of a line, both are perpendicular each other. The radical axis and the center of a line both are perpendicular each other here. So here the ultimate one is the radical axis s dash s11 minus s dash 11 is equal to 0. If you subtract any two circles, we will get straight line equation. Subtraction of two straight lines, two circles here, we got straight line here. Why? Because here I am subtracting this circle with this circle. If you subtract with this one, we will get the cancel the terms of x square y square, then we will get a straight line here. That is what we are doing here, and this is all about the radical axis. Radical axis is nothing but, let us take two circles here, and from that two circle I am taking one point is outside of the circle here. For that point I am finding the power of first circle and the power of second circle. If the power of first circle and the power of second circle both are equal at one point, similarly you can take one more point The power of first circle and the power of second circle is also same for the second point and third point also. If you join all the points, we will get the radical axis, and the radical axis and the center of a line both are perpendicular to each other. This is all about radical axis, and then some more basic concepts of radical axis here. Let us discuss about radical axis. Here, case 1 I am taking. If two circles are contacting at one point, touching each other, if two circles are touching each other at one point, this is S is equal 0 and this is S dash is equal 0, and this is having center C1 and this is having center C2. This is S is equal 0 and this is S dash is equal 0, and having for this one, so the power of this point is S11, and the power of this one, power of S is equal 0 and power of S dash is equal 0, that is S dash 11. So both, if they are both are equal, S dash 11 is equal to S dash 11, S11 is equal to S dash 11. S11 minus S dash 11, that is nothing but I am taking S1 minus S dash 11. This is the equation for this one. If you subtract these two circles, subtract any two circles, we will get one straight line, that is common tangent here. This is a common tangent. The equation of common tangent is here. This is nothing but radical axis, and this is also common tangent for two circles here. This is a common tangent for two circles and radical axis. This is case number 1, and the case number 2 here. If you take two circles touching internally, this is one circle, S is equal 0, and I am taking one more circle at touching one point, that is S dash is equal 0. This is circle center C1 and center C2. This circle is S dash is equal 0. The power of S is equal 0. Power of S is equal 0 at point P is x comma y, that is S11 is S11. This is the value, and the power of S dash is equal 0 at P of x comma y, that is S1 S dash 11. That is here, if these two are equal, then those are the collection of the locus of points of these points is called radical axis. This point, this line is called as tangent line, that is nothing but S minus S dash is equal 0. If you subtract the circle, if you subtract any two circles equation, we will get straight line. That straight line equation is called tangent, common tangent. This is common tangent, and radical axis for this circles here. This is case 2, and the case 3 here. Case 3, if two circles are intersecting each other, this is S is equal 0 and this is S dash is equal 0, and these two circles are intersecting at 2 points, that is P and Q here. P and Q here. The power of this one is S11, the power of this circle is S dash 11. All if they are equal for P and Q at P and Q, and S minus S dash is equal 0. This is the equation of common tangent. This is the equation of common tangent. This is the radical axis for this case 3 here. This is all about the radical axis here, and here some important points of a radical axis here. And the radical axis of two circles is a straight line, is perpendicular to the line joining of center of two circles. Already we discussed in last part. Sorry, if two circles are like this. The radical axis always is perpendicular to the center of two circles here. This is the first point here. The radical axis. The second point is the radical axis of two circles bisect each of common tangent. This common tangent always bisects to each other. This is all about the second point. And the third point, the equation of radical axis. The equation of radical axis is if two circles are s is equal 0 and s dash is equal 0, then the equation of a tangent, or sorry, here tangent in sometimes radical axis for generally. So the equation of radical axis is s minus s dash. If you subtract two circles, we will get a straight line equation. The straight line equation is nothing but radical axis. In some cases it will become common tangent. This is all about the third point. If two circles intersect each other, then their common chord is the radical axis. If two circles intersecting each other, then the common tangent is called radical axis. And the fifth point is if two circles touch each other internally, this is the common tangent is a radical axis for this point. And this is important one, the number of radical axes for n number of circles. For number of radical axes for n number of circle is nc2. This is a combinations for radical axis. nc2 will get the number of radical axes for n number of circles here. This is the important point here. And there is no radical axis for concentric circle. For example, concentric circle I am drawing here. So concentric circle, these are the concentric circle. Concentric circle is nothing but having only one center, common center for all the circles, and having different radiuses is called concentric circle. For those concentric circle, there is no radical there is no radical axis. This is all about the radical axis. And the next topic is radical center. Radical center. See, generally, if let's consider S1 is equal 0 and S2 is equal 0 and S3 is equal 0 are three circles. Here I am taking circle. This is S1 is equal 0 and I am taking one more circle. Otherwise here I am taking S2 is equal 0 and I am taking one more circle. This is S3 is equal 0. Here I am taking three circles having off center C1, C2, C3, three centers. S1 is equal 0, S2 is equal 0 and S3 is equal 0. Three circles here, and the radical axis for H1 and S2. Radical axis I am drawing here. This is the H1 and S2. H1 minus S2 is equal 0. This is the radical axis. That is nothing but H1 is equal to x square plus y square plus 2gx plus 2gx 2g1x plus 2f1y plus c1 is equal 0 and S2 is equal x square plus y square plus 2g2x plus 2f2y plus c2 is equal 0 and S3 is equal x square plus y square plus 2f 2g3x 2f3y plus c3 is equal 0. These are the three circles equation. Here this is the radical axis for these two circles, that is h1 minus h2 is equal 0, and this is the radical axis for h1 and h3, that is h1 minus h3 is equal 0. This is a straight line, this is also straight line, and the radical axis for h2 minus h3 is equal 0. Here if you subtract the equations of these two circles, we will get straight line equation. This is h1 minus h2 is equal 0, and again in the same manner h1 minus h3, this is also straight line and this is also straight line. All these three straight lines are radical axis. Here radical axis, this is radical axis, this is also radical axis, this is also radical axis. The point of intersection of radical axis is called radical center. Radical center here. The point of intersection of all radical axis is called radical center. This is all about the radical center here, and here all the three lines are framed by subtracting of two circles taken by common for radical axis. Here the combination of radical axis is a radical center. The intersection of radical axis is a radical center. This is all about the radical center here. Here some more important points of a radical center here. In that, the first point is the point of intersection of a radical axis of three circles is called radical center. This is the definition of radical center. The point of intersection of three radical axes is called radical center. This is a radical center. This is the definition of radical center. And the second point is the length of tangent from a radical center of three circles to the three circle are equal. The length of all the circles to the radical axis are equal. This is the point about the second here. And the third point is, if P is the radical center, and P is the length of the tangent from point P to the one of the three circles, then the circle P and the radius is PA cuts the remaining circles orthogonally. So I am taking these three circles here. So for this one, this is the point P is the radical axis, this is the point P is the radical center. If you draw a tangent to a circle, this tangent line cut the remaining circles orthogonally. So this is the condition all about the third point here. And the fourth one, the radical center of three circles described by sides of a triangle as the diameter of the orthocenter. For example, I am taking a triangle here. I am taking a triangle, so smaller triangle. I am taking a small triangle here. So we need to draw circles as a diameter of each side. So it will become like this. So diameter of each side. This is the diameter for each circle. The intersection of the circles family, the tangents run perpendicular, so not perpendicular. The medians are drawn here. The joining of this point is called orthocenter. So the intersection of all the circles is called orthocenter of a radical. This is nothing but radical point of 3 circles here, radical point of 3 circles here. This is S is equal 0, S1 is equal 0, S2 is equal 0, this is S3 is equal 0. This is all about the radical center points here. And the next topic is the two circles touches the coordinate axis. Two circles touches the coordinate axis here. This is the topic here. The two circles touches the coordinate axis, and in that one I am taking the coordinate axis of case 1. Here this is the quadrant 1 here, so this is x dash, y dash. So here one circle is drawing here, and according to that one more circle is drawing here. So the point of contact at x axis and y axis, this is A and this is B, x1 and y1. So this is x1, x2, y2. So the equation of this line, is y is equal to x here. This is the first case here, and the second case is if two circles touching at one point, then this is also touching at point A, point B. This is the equation of this line is y is equal to x again. Here x is equal to A is equal to x1 comma y1 and b is equal to x2 comma y2. Here this equation of this line is y is equal to x here, and one more case is there. This is a and this is one circle, and this is also one circle here. Here the length, this is touching at point A, this is touching at point B. Then the equation of this line is y is equal to minus x, and the final one is this is last quadrant here. Here four cases are there, one circle and touching one more circle. This is touching to one more circle at one point A and point B. So the line, this is called y is equal to minus x here. This is x dash, y dash, x dash, y dash. This is the line here, x dash, x is x dash, y dash here. Here this is case number 1 and 2 and 3 and 4 cases are there here. In these 4 cases, here the length of AB, in these 4 cases the length of AB is here, the length of AB. If you want to find the length of AB is equal, the length of AB is equal root 2 into mod of x1 minus y1. This is the formula for length of AB here, root 2 into x2, root 2 into modulus of x1 minus y1. This is the length of A and B point on a coordinate axis. This is the 4 cases about 2 circles touching the coordinate axis. Here 2 system of circles. Here this is S is equal 0 and this is S dash is equal 0. Here in each and every case 2 circles are there. So the equation of AB line in 2 cases, this is the formula for the length of AB is, so root 2 into modulus of x1 minus y1. This is all about the system of circle. In this system of circle, we discuss in this session radical axis and radical center, and 2 circle touches the coordinate axis. This is all about the system of circle. In next session we will discuss about the JEE problems of system of circles. Thank you.